So derivatives using the definition. We know that from the previous video that f prime of x by definition, so derivative of f, already noted by f prime, so f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x over h. Okay, so we're gonna use this definition of derivative to find the derivative of polynomial functions. So let's say you have your function f of x equals x squared, and I want to find its derivative f prime of x using the definition. So what is f prime of x here? So f prime of x is equal to, using the definition, limit as h tends to 0 of f of x plus h minus f of x over h, which is equal to limit as h tends to 0. Now f of x plus h, you have to replace x here by x plus h in your function, so it becomes limit at h as h tends to 0 of x plus h squared. Okay, I just replaced x by x plus h to the power 2 because it is of power 2, minus f of x. Now f of x is given to be x squared, just replace it here, it's x squared over h. Okay, so I will repeat what I did is f of x plus h is x plus h squared. I just replaced x by x plus h, so it becomes x plus h to the power 2 minus f of x. F of x, it's your function given, which is x squared over h. Now you just distribute, so equals limit as h tends to 0. Now x plus h squared is of the form of a plus b squared, which is a squared plus 2ab plus b squared. It's an identity. So x squared plus 2ab, so 2xh plus b squared, so plus h squared, minus x squared over h. Simplify. X squared minus x squared, they cancel out, so you'll be left with limit as h tends to 0 of 2xh plus h squared over h. Now before replacing h by 0, you have to factorize. Why? Because if you replace h by 0, you will get, so h here tends to 0, so that's why you have to replace by 0. You will get 2x times 0, which is 0, plus 0 squared, so 0 over 0, which is indetermination form. And when you're finding the limit at a point, you have to factorize. Remember, you have to factorize, simplify, and then replace by 0. Okay, so let's factorize. So equal limit as h tends to 0, 2xh plus h squared, we can take h as a common factor. We have h common factor, so h, you'll be left with 2x plus h. Okay, I took h out over h. Once I factorize, you have to simplify before replacing, otherwise you will get indetermination form. So you simplify h over h, they cancel out, so you'll be left with limit as h tends to 0 of 2x plus h. Now you replace h by 0. Why by 0? Because we're taking the limit as h tends to 0. Okay, this is the definition of the derivative of a function. Always h tends to 0. So it's equal to the limit no, without limit. Now when you replace, don't write limit. So it's equal to 2x plus h is 0, so plus 0, which is 2x. So actually the derivative f prime is equal to 2x of my function x squared. So I proved that the derivative of x squared, my function x, f of x equal x squared, is equal to 2x. Okay, so this is how I found the derivative of my function x squared. If I asked you to find f prime at 1, once you find the derivative of your function, you just replace x by the value given here. X is 1, so f prime of 1 is 2 times 1, which is 2. This means that the slope of your function at x equals 1 is equal to 2. So the slope at x equals 1 is 2. This is the meaning of derivative of a function at a point. Let's take another example in the next video.